Alright, so this is a review of stoichiometry for anyone who might need it. We're going to focus specifically on problems involving just moles and grams. So the first example I'm going to do involves a thermite reaction, giving you some examples of how it's used. It was also used to help put space shuttles up in outer space, and so we see that this is a single replacement reaction between aluminum and iron 3 oxide. And I want to know how many moles of the iron 3 oxide in aluminum were needed to make 15 grams of aluminum oxide. So this is a two-part problem because you need to find out the amount of iron 3 oxide and aluminum. So I'm just going to take one part of it at a time. We can tell this is a stoichiometry problem because we are switching between chemical substances. If we were not given a balanced equation, we would need to create one. This time we were, so we're going to start with what we're given, which was the 15 grams of aluminum oxide. I want to make sure I cancel that out, so the grams of aluminum oxide need to go in the denominator. I want to find moles of iron 3 oxide, so that would go in my numerator. Anytime I'm dealing with grams and conversions, I need molar masses. So if I add the mass of 2 aluminums and 3 oxygens from the periodic table together, you should get roughly 101.96. That is equal to 1 mole of aluminum oxide. If you have moles in your conversion factor, by definition that's all equivalent to 1 mole, so 1 goes in front of Fe2O3. And now I need to look at the coefficients in my balanced equation so I can relate the moles of aluminum oxide to the moles of iron 3 oxide. I see that aluminum oxide and iron 3 oxide are in a 1-to-1 ratio, so both of them get coefficients of 1. The grams of aluminum oxide are going to cancel out, and I would multiply 15 times 1, giving me 15. 1 and 101.96 together, so I'm going to end up dividing 15 by 101.96. The 1 mole and the coefficients do not affect my sig figs. Those are exact values. Those are defined quantities. While the masses of the aluminum oxide, the molar mass, as well as the mass of the aluminum oxide that I started with, are measured quantities, and so we need 3 sig figs in our answer, 0.147. I would do the same thing now with aluminum. I'm going to figure out how much aluminum I would need to make 15 grams of aluminum oxide. So I start again with what I'm given. This first part's going to look exactly the same. I want to cancel out the grams of aluminum oxide, so I put it on the bottom. I want to find moles of aluminum, so those go in my numerator. And now I use molar mass again for grams. You only get to use molar masses with grams, and you only get to use 1 with moles. I need to relate the aluminum oxide to the aluminum, and I see this time it's in a 2-to-1 ratio. So the 1 goes with aluminum oxide again, but 2 goes with the moles of aluminum, again according to my balanced equation. When I cancel out the grams of aluminum oxide, I would multiply 15 times 2, giving me 30. I would divide it by 101.96. Again, the 2 does not count towards sig figs, as the 1s don't either. So I have 3 sig figs in the 15.0, 5 in the 101.96. So I want 3 in my answer, 0.294. So because it was a 1-to-2 ratio between the iron 3 oxide and aluminum, according to the balanced equation, we see we needed roughly double the amount of aluminum in moles that we did of the iron 3 oxide. The second example I give you gives you the amount of iron 3 chloride that you start with, and you're told you combined it with H2S to make iron 3 sulfide and hydrochloric acid. And so I want to know how many grams of the two products are made. So I would start with by writing an equation so that I can figure out what the ratios are between these different substances. I've told you what the two reactants are, and I've told you what the two products are. So I'm just going to go through step by step. I have 1 of each element on both sides of the equation, so this is a pretty straightforward reaction to balance. I have 1 Fe on the reactant side. I have 2 on the product side, so I need 2 on the reactant side. That gives me a total of 6 chlorine atoms, so I need 6 chlorine atoms on my product side. When I do that, that also gives me 6 hydrogen atoms on my product side, so I need 6 hydrogen atoms on my reactant side, and that takes care of the sulfurs as well. So the first part is taking those grams of iron 3 chloride and figuring out how many grams of HCl I can make. So this is a straight grams problem, so it will involve molar masses for both parts of our conversion. I start with the 90 grams of FeCl3. I cancel out the grams of FeCl3, and this time, because I want to find grams of HCl, that would go in my numerator. I need to find the molar mass of 3 Cls and 1 Fe. I got that to be 162.20. I need to find the mass of 1H and Cl, 36.46. And now I need to look at the coefficients for my equation. I see that FeCl3 has a coefficient of 2, while HCl has a coefficient of 6. So I need to account for that proportion in my conversion factor before I get to multiply and divide. This time we would have 3 numbers or 3 values that would affect the significant figures: the 90.0, the 36.46, and the 162.20. 90.0 has the fewest sig figs because we're multiplying and dividing, so I want 3 sig figs in my answer. I calculated that to be 60.7 grams of hydrochloric acid. The last part will be taking the grams of FeCl3 and determining how many grams of iron 3 sulfide are going to be made as a result of that. I start again with what I'm given, the 90 grams of FeCl3. I want to get rid of FeCl3, so it goes in the numerator. I want to find grams of Fe2S3 this time, so that goes in my numerator. Both are grams, so both require molar masses, so I use the same molar mass for FeCl3 that I did previously. I would take 2 iron masses and 3 sulfur masses to get the 207.88. And now I need to relate these two to one another according to the balanced equation. It looks to me that there are 2 FeCl3s for every 1 Fe2S3. So I've accounted for that ratio. The grams of FeCl3 cancel out. I have 3 values again that affect my sig figs: 90.0, the 207.88, and the 162.20. 90.0 has the fewest sig figs, so I want 3 in my answer, 57.7 grams. Okay, so hopefully this was a good review if you needed a refresher on stoichiometry.